I know in class already they might have already explained to you when they say resistors are in series and when they say resistors are in parallel. So basically, we say resistors are in series when the same current flows through them. So let's say if from this resistor, let's say if 10 amps is flowing through this circuit, then that means the 10 amps will flow through this one, and the same 10 amps will also flow through R2. So that is why they say both of these resistors are in circuit, meaning the same current, this 10 amps will continue to flow through the whole of this circuit and back, so making them in series. And another condition is that they said there is no junction between them, as already they explained in class that a junction is a point where current splits or divide. So there's no junction between them. So basically, this is what I also use simply in a layman's term sometimes to identify resistors in series. So I always ask myself, let's say if current starts to flow from here, this current starts to flow from, so when it gets here, is it that is there any option for it to pass? No, there's no any option. It just have only one path to take. So meaning they are in series. Since there's just only one path, meaning when the current from here it gets here, it just moves all the way back, and there's just only one path for it. So basically, sometimes that is also one way you can easily use to detect whether they are in series aside the definitions. So there's just only one path for current to flow, so making it in series. So let's say practically in your rooms, in rooms mostly they connect this thing, light bulbs in series. So some of you might be asking yourself, where will I be applying this? So light bulbs are wired in series, so that that's why sometimes when you switch switch on, it will turn on about 4 lights or 2 lights. So that is the concept of series resistance. So let's move on forward. Looking at the second circuit, you see that we have R1 here, R2, and R3. And once you look at this circuit, although there is a junction here, we observe that there is a junction, and the definition for a junction was that is where a junction is a point where current splits or divides. So let's say if we have current flowing from here, let's name it I1. So if we have current flowing from here, I1, so when I1 gets to this junction, it will split up. So some will come here, some will come here. So none of these resistors are in series, sorry. None of these resistors in this circuit are in series, so none of them are in series. So this was just an example I wanted you to understand. So what is next? I wanted you to take you through the practicals. How do we calculate resistors in series? So resistors in series can be found, so we can say total resistance, which we normally call it RT, should be equals to the sum. It's typically the sum of all the resistors in series, since they are in series and it's just one closed path. So for the figure 1, we say the total resistance equals to R1 plus R2. So basically, we have a general formula that we use to calculate resistors in series and resistors in parallel. So this is the formula which is used to calculate resistors in series and resistors in parallel. So you just sum all of them just like this. R1, they summed R1, so RT here is equals to R1, R2 plus R3 plus 2. It's just the sum to infinity. If there are even 1000 resistors and all of them are in series, you just add them up. Okay, so let us move to a simulation. I have a simulation here that will really show us what the resistors that are in series and how the current flows. So, but just as I was saying, you see that the current started flowing from this voltage source, and from this voltage source, it started moving to this resistor. Then it moved to this resistor. Then it got to this branch. Then it came back all the way back. Meaning there's no path for it here. The current is just moving in a straight line and back. The same current, if let's say 10 amps is flowing through this one, the same 10 amps will flow through this and all the way back. So that is how basically it is. So I think from here, if I want us to take an example so that we really understand, in case there's a question, we'll know how to handle it. So this is a problem. Problem one. They said, what is the total resistance in the circuit below? So as we said, note I forgot to add one thing. All the units are in ohms. Resistance is measured in ohms, and voltage is measured in volts, and um, current is measured in amps. So these are in ohms. I forgot to add them. So now we know the formula already. It is equals to the sum of resistors. So now we say our RT here is equals to our R1 plus R2 plus dot 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 dot, dot up to Rn. So now here, how do you solve this question? We have our RT here is equals to our 20 plus the 11. This and this are in series. This resistor is in series with this, and it's in series with this, and this, and this. These two are, everything here is in series, so we simply just add them up. So we have 20 plus 11 plus 50 plus 18 plus 17. So when we do the math, we will get 116 ohms. So please always make sure to write the units. If you are working for voltage, you know the answer should be in volt. When we are calculating resistance, when you finish, you don't leave the units, because when you leave the units out, if it is a theory question, they will mark you wrong, because they will give you not get the full mark. Yeah. So if the question is like maybe two and you write and you leave the units, maybe you will not do it, you will not get the full mark. And maybe if it's MCQ, if it is MCQ, they can set it like uh since the answer is 116 ohm, they can have 116 volt, 116 amp, 116 ohm, just to confuse people. So the questions are really tricky. The course is not difficult. So I want us to move on to parallel and parallel resistors. So